Hey, this video, let's go over 712 and 713. They're really similar. I'm going to do 713 in detail because actually that is one of the, I think, two problems in this whole thing. They actually put the wrong answer in the back of the book, so hopefully no one's wasted too much time trying to figure out where they went wrong. 713 is the wrong answer, 712 is right. And then later on in the book, I think there's one other place where they have a wrong answer, which is really frustrating. But this is one. Okay, 712, you have 300 meters of fence to make a rectangular enclosure, and then you want to split it in two parts. So what dimensions should you have to have the maximum possible area? So this again is where you have an area formula and a perimeter formula, and you want to maximize the area. So first you draw a picture. Always draw the picture. Okay, and then we have one thing in the middle here. So we'll call this L, this is L, this is W, this is W, and we have another W because we have a fence down the middle. Okay, so our perimeter, the amount of fence we have, which is like the perimeter is 2 L's, so that equals. Perimeter is 2 L's plus 3 W's. Okay, 1, 2, 3. Okay, and we know that they tell us that's only 300. We have 300. So 2L plus 3W equals 300. Now, what is the area? The area is just length times width. Doesn't matter, there's one in the middle for the area. We want this to be big, but we have an L and a W. That's a problem. So you got to solve for one of them here. Doesn't matter which one, like maybe solve for L, plug it into here, and then you can have only W's, and then you can figure out the W that gives you the biggest area because it'll be a quadratic. You'll have a W plus a W squared, so it'll be a quadratic, and then you'd use negative B over 2A to figure out what the peak is, what W gives you the best, or what L gives you the best. And if you know L, you know W, because you're going to get a formula for L here, plug it in here, and you can figure that out. Okay, so that's the idea. So I'll let you do that algebra. Again, you solve for L here in this formula. Solve for L, get an L by itself, plug it into here, you're going to get a W squared term and a W term, and then you can use negative B over 2A. Now, 713 is very similar, but they make it a little bit harder, which is kind of cool. They make the cost of the fence. Now we have the cost of the fence. So I think it's like kind of the same idea. I'm going to change that to a 13. We have a rectangular enclosure. Oh, let me read it carefully here. So 713 says you have $6,000 to build this fence. The material costs $20 per meter. But you also want to have two partitions across the width of the enclosure. So we have two of them somewhere. Okay, to break up our cows, have 3 different places. And those are cheaper. Those are only $15 per meter. Okay, so what is the maximum area you can achieve for the enclosure since you have $6,000? Okay, so let's call them things. Okay, we have a W, a W, a W, a W, an L, and an L. Obviously, we want the area to be big. Area is length times W. We want the area to be big. And we have a cost here. So what is the cost? And okay, so what is the cost? So the cost is, let's see, 2 W's, the outside costs $20 per meter. Okay, so that's 20 times, so $20 per meter times the number of meters. Again, this is where units really helps. $20 per meter times the number of meters. So the number of meters for the outside is a W, an L, and an L. So 2W plus 2L. Right, those are $20 per meter, and here's the number of meters, plus $15 per meter for the 2 W's inside, 2 W's inside. And again, that will give you dollars, and we know that's equal to 6,000. And this is why we studied units before. Again, dollars per meter times meters equals dollars. Okay, so notice here we have a formula then. We have this thing here, only L's and W's. So like before, we can solve for L or W, stick it into here, get a formula then for a parabola, and it'll be like that again. It'll open down, and we want to find the maximum area we can have given that we only have $6,000 to buy all these things. Okay, so it's a lot of algebra, so we might as well get started. So let's multiply this out. So 20 times 2w is 40w plus 20 times 2l is 40l plus 15 times 2w is 30w equals 6,000. Let's see, 40w plus 7w is 70w. So 40l plus 70w is equal to 6,000. Now we have a choice. Do we want to solve for L or solve for W? And you know, there's no right or wrong. Let's solve for L just because why not? So put the W on the other side. So I have 40L is equal to 6,000 minus 70W. Or finally, and I'm running out of room, so I'll write up here, divide both sides by 40. 6,000 divided by 40, I think, is a pretty number. So 6,000 divided by 40 is 150. That's a very pretty number. So finally we have L is equal to 150 minus 70 divided by 40. That's 7/4. 7/4 is 1 3/4 is 1.75. So minus 1.75 W. Okay, that's what L is. Now we plug that in to here. So our area then is L times W, which is equal to this times W. So we just put a W on each side here. So we have area is equal to 150 W minus 1.75 W squared, right? So just length times W, just add a W, 150 W. Okay, so we want to make this, what W makes this the biggest? This is a parabola, it's a quadratic, right? We got W squared and a W. And so now we just do negative B over 2A. So the W that makes it the biggest is negative B. This is our B, right? The one by the W is the B. This is our A. It's kind of backwards, right? The W squared term is backwards, but with the minus there, it just, makes sense, right? Backwards. So negative 150 divided by 2A, 2 times negative 1.75. That's 150 divided by 3.5, which I don't think that's very beautiful. Divided by 3.5 is it's horrible, 42.857. 42.857. That's what the width should be. Now the length then, okay, so that's our width. So that's equal to the width. And if we want to find the length, we got to use this formula. So the length is equal to 150 minus 1.75 times W, right? And W is that, so 42.857. So 150 minus 1.75 times that business, so times 1.75. I get exactly 75. That's pretty awesome. So the length is a pretty number, but the width is not a pretty number. Okay, so then, what's the question ask? It says, what is the maximum area you can achieve? So the maximum area you can achieve then is length times width, which is 75 times 42.857. So we can finally answer the question. 75 times 42.857, which is 3214.275. 3214.275. And whatever the units are, meters squared, feet squared, it's per meter, looks like, per meter. So meters squared, that's our area. Now, the book said, the answers in the back said that it's 4285.71, so that's wrong. I know that that came up before too, and I always remember, oh, one of these is wrong. Okay, so that's how you do it. The 7.14 is very similar. You use the areas for squares and circles. On these wire tricks, you just add the area of a square plus the area of a circle, make a parabola out of it, find maximum minimums, things like that. It's kind of cool problems. Okay, good. Hope that helps here. And again, hope no one got too confused because they gave the wrong answer. That's terrible. All right, thanks for listening.